Math 3, Unit 10, Section A or 1. Today we are going to be talking about a little bit about, it's going to kind of give us a baseline for the unit circle, which we'll get into more later, and then also a review of like our trig functions, Pythagorean theorem. So here on example 1, in order to solve this, we're going to have to use the Pythagorean theorem. You guys are amazing that you figured that out. Just kidding. Okay, so what is always going to be my C value? The hypotenuse. Good. So that's my C. Everything else, it doesn't matter the order that you put it in. Okay, and so we have a squared plus b squared equals c squared. So we have x squared plus 9 squared equals 15 squared. X squared plus 81 equals 225. We subtract 81 to both sides, and we get x squared equals 144. But we don't want the answer of x, so what do? Square root of both sides, and x equals 12. Now, normally when we take the square root of both sides, the answer could be plus or minus, but are we going to have a negative length? No, so that's why it's only going to be a positive 12. So far, so good? Okay. Example 2. So on these next examples, we're going to be talking about special right triangles. So I don't know if you guys remembered these, but these you're going to need to memorize. We're going to want them handy as you're completing homework, and hopefully as you practice them, you'll remember them. But when you have a 45, 45, 90 triangle, these two sides will be the same lengths. That's why they're both labeled as A's. Okay? My hypotenuse will be a root 2. So that means that if both of these sides were 3, the hypotenuse would be 3 root 2 because that has the same value in front. Does that make sense? So basically, if you know one side on a 45, 45, 90 triangle, you can find all the other sides based on that information. Normally, in order to use the Pythagorean theorem, you have to know two sides. With the special right triangles and our trig functions, you really only need to know one side in order to find the answers. Okay? On the 30, 60, 90 triangle, you'll notice across from the 30 is your A, across from 60 is a root 3, and across from the 90 is 2a. What often happens is if you have one side, I use this as a formula and solve for a. Because once you know what a is, you can plug that in and find all the other sides. Is that clear? Okay, so on this one, if this is 30, then the angle here that's missing is what? 60. Okay, and so 60, whatever is across from 60, that is the value that I have matches with the 60 here. Does that make sense? Okay, so that means I'm going to write an equation in order to find A and C. And so across from my 60, it's a root 3. So I'm going to write a root 3 equals 7 root 3. And in order to get a by itself, what would I do? I would divide by root 3, because in order to get rid of the a and the root 3 are multiplying, so I divide by root 3 to both sides. So these cancel, and I get a equals 7. Okay, now granted I have an a here, but that might not actually be the answer. In this case it does work that way, but notice across from the 30 is just the a value. Okay, so that means that a does equal 7. Across from the 90 degree is 2a. So that means that c is really going to be 2 times 7. So my c is going to be 14. And then we already found that angle B equals 60 degrees.
So why would it sometimes not be the right?
Well, okay, so see how I labeled this as A's? Maybe we should label them as X's. It just happened that when I was solving for A, this side is also A, but they're not exactly the same A's.
So they're not the same number,
It just, think of it that like maybe these should have been labeled more like as X and Y. Okay, and so we solve for A, and then the X side is really whatever 30 equals. Does that make sense? So maybe we should change this. And you could, yeah, or I don't know. sorry, it would be x over here and y here. Okay. So 45, if this is a 45, what will angle A be down here?
45.
Also a 45 degrees. So we know, though, what's across from the 90. Okay, and so what would be the formula for setting this up?
It would be
3 root 2 equals, what's across from the 90 on the 45, 45? A root 2. And so in order to solve for A, what would I do? Divide by root 2 to both sides. These cancel, and what does A equal? Good. So now when we're plugging these in, we know that each of these sides are actually A. So that means A over here equals 3. B equals 3. And then we already found that angle A is 45 degrees. Any questions with that? Sometimes people will remember these as, instead of having 2A, A, and A root 3, you could also remember them as 1, 2, and 1 root 3. And whatever number you get, you're basically multiplying it by 1, or multiplying it by 2, or multiplying it by 1 root 3. And then the same thing here, 1, 1, and 1 root 2. Or you can remember them as the letters, where we set them up the same way as we did. So either way works. We'll kind of practice it different ways, and whatever makes the most sense to you, do it that way. Okay, so back in Math 2, you guys learned SOHCAHTOA. Do you guys remember that? And so these really split up, right, your SOHCAHTOA, and each of them represent a different trig function. Sine for so, opposite over hypotenuse. Ca is cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So remember, when you're saying opposite, opposite is across. Adjacent means next to the angle. And your hypotenuse is always over or across from your 90-degree angle. Okay? So we're trying to find x here on example 4. Okay? And so the first thing that you would do is, okay, I know 71 degrees. And if you look at this, we are trying to find what is opposite, and 24 is the hypotenuse. Is everybody okay with that? Does that make sense? So the x is opposite of the angle we know, and 24 is hypotenuse. So therefore, which trig function should I use? Good. Your sine, your so, because that's the one that has opposite over hypotenuse. So we would write this as sine of 71 equals, opposite is going to be x over hypotenuse, which is 24. Now what I want you to do first is solve for x. Get x by itself, and then we'll plug in our information for trig. Okay, and so how would I get rid of the 24 in the denominator here?
Multiply by 24.
Very good. Multiply by 24 is correct. So these cancel out. We have x by itself. So that means x equals 24 times the sine of 71. So this is where we're going to get our calculator. So if you don't have a scientific calculator, I would get one out or borrow one from me, so that you can practice. And so for me and my calculator, I would type in first sine, so that's your sine key, and then type in 71, and then enter. And you get this big long decimal. You leave that there, and you go times 24 equals. And you get 22.692, because they asked you in the problem to round to the nearest 1,000. So that means that x equals 22.692. Okay, any questions about that one? Okay, let's go to example 5 then. So here, again, I have a 28 degrees. On this one, what would 15 represent? Is it opposite, adjacent, or hypotenuse? Opposite. And x then would represent what? Adjacent. Okay, now granted, there are 2 lines next to the 28 degrees, but this line for sure is the what? Hypotenuse. So that means this has to be adjacent. Is that clear?
So just whatever ones have the numbers or an X?
Mm-hmm.
Okay.
So now, and since I have O and A, opposite and adjacent, which trig function will I use? Very good, tangent. So we write this as tan of 28 equals 15 over x. Now, again, we want to get x by itself. Do you guys agree? And so there's multiple ways of doing this, but I would start by multiplying by x to both sides to eliminate the fraction. And then what would you do now to get x by itself? So we have x times tan 28 equals 15. What would I do? You would divide by tangent of 28 to both sides. Now, there will be a time, and maybe that time for you is now, but that you'll figure out that every single time you have a problem set up in this way, that you're going to end up with 15 divided by tangent equals x. But if you don't, work through the process to figure out to get x by itself. Okay? But if you can skip some of those steps, and you just know that x will end up being 15 divided by tangent of 28, it's okay to do that.
So always be 15 or any number?
Well, it depends on what the problem is set up as. But if you have x in the denominator, it'll always end up being this number divided by that equals x, if x starts in the denominator. Okay? So now we need to solve for x. Okay? So we know that x is 15 divided by tan of 28, tangent of 28. So in your calculator, we're going to have to type it this way first. 15 divided by, and then I believe you should use parentheses to be safe on your calculator. And then we're going to do tan of 28, and then close your parentheses. And we press enter then. And you should get 28.211. Because we're rounding to the nearest thousandth. And since the 8 is bigger than 5, or we round up, right? Do I need to go through plugging that into the calculator again? We're all good? Okay. All right, example 6. So example 6, we have 65 degrees. What is the 8 root 5?
It's the adjacent.
Good, adjacent, and x is
Hypotenuse.
hypotenuse. Okay, so adjacent and hypotenuse will be what?
Cosine.
Good, cosine. So we write cosine of 65 equals adjacent, which is 8 root 5 over x. Now, do you know what x is going to end up equaling here?
Cosine of 65.
X equals 8 root 5 over cosine 65.
Good. That's exactly it. So if you know that, just write it. If you don't know that, let's work through it. So what do I mean by that? I would multiply by x to both sides in order to get the x out of the denominator. So this cancels. So now I have x times cosine 65 equals 8 root 5. And I want to get x by itself. And so the last thing I would do here is what?
Divide by cosine 65.
Very good. Divide by cosine 65 to both sides. So this cancels. So we end up getting x equals, and we're going to plug this into our calculator again. So this one even has a little bit more. So we're going to write 8. And then remember, you find the square root button is right above the x squared. So I'm going to go second square root of 5. Okay? And since that has a parenthesis there, I'm going to close that parenthesis, okay? And then we're going to go divided by, and I'm going to make another parenthesis for my cosine, and we have cosine of 65. And the reason why we're using parentheses is to make sure that order of operations is followed. Because otherwise, sometimes your calculators will, if you don't have the parentheses, it thinks that it has to do things in order of operations. So you have to be careful. Okay, and so we press enter, and we should get 42.328. Oh, sorry, 42.328 is your answer for X.
Do you always have to round it to the 1,000?
Whatever the instructions tell you to do. Okay? All right, this last one is slightly different. And you did do this back in Math 3, but we just want to make sure you remember. So notice this time we don't know what the angle is. Okay? What you also need to be careful of is that when you write your answer, you should also include the degree. Okay? So on this one, from this angle, what is 25?
It's the
Adjacent. And 31 is hypotenuse. Good. And so we are going to write this as what?
cosine.
Cosine x equals 25 over 31. Now, this is where you're going to end up doing your inverse function. Anytime you are finding the degree, you're using your inverse. If you are looking at your calculator, your inverse function is right above your actual function. And see how it says cosine to the -1? That's what you use for finding your inverse, for finding the actual degrees. Okay, and so what you're going to do, and I'm going to write it how you type it into your calculator here, but you would write in or type in cosine to -1, and then I'd end up having to use parentheses for 25 divided by 31, so I can make that into a decimal, and that will equal x. That will end up equaling your degrees. And so we'll go ahead and plug this in together. And so again, I'm going to do second and cosine of -1, and you know you're finding your inverse because you can see on there that it says -1. And then it actually already made the parenthesis for you. So we're going to go inside, we have 25 divided by 31, and then we close our parenthesis and press enter. And it gives me, this is my degree. So that's 36.249 degrees. And that's it. Do you guys have any questions on that?